next type is going to be double displacement. In double displacement, we're looking for two ionic compounds. And what you're going to do is you're going to swap the positives. So this positive will swap places with that positive, and you'll still end up with this is positive, that's negative. Over here, that's positive, that's negative. So positive, negative, positive, negative. So look for two ionic compounds. Rearrange them. What you need to be able to do these is you have to know your polyatomic ions to be able to write the formulas, and you're going to have to know your solubility rules. We're going to cross out any spectator ions, so anything that is soluble in the beginning and is soluble in the end, we just cross it out because it didn't do anything. I think the easiest way to do these is to write the equation first, and then to figure out what your product is, and then write the ions that are required to make that product. So let me just show you. So I have 0.1 molar solutions of lead 2 nitrate. So lead 2, that's Pb with a 2 plus. Nitrate is NO3 with a 1 minus. So I'm going to have PbNO3 2. And magnesium iodide, so Mgi2. Because that's a 2 plus and iodide is a 1 minus. Right away, I know that nitrate's always soluble, so when I swap these and magnesiums with the nitrate, that's going to be the soluble product. The insoluble product is going to be the lead 2 iodide, which is a bright yellow color. So PbI2 is going to be my insoluble product. Now, I know that I can leave out anything that's not part of that PbI2. So, what I'm going to have is I'm going to have Pb2 plus, and I'm going to have 2 iodide ions. So, iodide is a 1 minus, there's going to be 2 of them, and Pb is a 2 plus. So I just figured out what my product was, and then looked at what I would need to make those. The Pb2 plus came from the lead 2 nitrate solution, and the 2 iodides came from the magnesium iodide. And that's my final balanced answer. Next I have a solution of sodium phosphate. So phosphate is PO4 with a 3 minus charge. Sodium is a 1 plus, so it'll be Ne3PO4. Is added to a solution of aluminum nitrate. So I have aluminum is a 3 plus, and nitrate is a 1 minus, so NO3, 3. Alright, and I've got a double displacement, and again, nitrate's always soluble, so they're making it easy for us. So I know that the sodium's always soluble too. So when the sodium pairs with the nitrate, whoops, that's definitely going to be soluble. My insoluble product is going to be the aluminum phosphate. So aluminum is a 3 plus, phosphate 3 minus, so those charges are balanced. I also know that phosphates are generally insoluble, so unless they're with alkali metals. So oops, that helps too. And then I can say, to make this compound, I needed an aluminum ion, Al3 plus, and I need 1 phosphate ion, PO4, 3 minus, and that's balanced. Final answer. So next I have a solution of potassium phosphate. Potassium is K with a plus charge. Phosphate, oops, K3. Phosphate is PO4 with a 3 minus, so I'm going to need 3 Ks and 1 phosphate, K3PO4. Alright, it's mixed with a solution of calcium acetate. Calcium is a 2 plus. Acetate is CH3COO, and it has a 1 minus charge, so I'm going to need 2 acetates for 1 calcium. Alright, so right away I know that potassium is always soluble, and actually acetate is too. So it does form a weak acid though, so if there was an H plus here, I would make that a product where acetate wouldn't be a spectator. But yes, acetate is soluble, so in this case it is a spectator. They won't do anything. I'm going to make calcium phosphate. So Ca3, PO4, 2. And that balances out the 3 minus of the phosphate with the 2 plus of the calcium. So now I know what ions I need. Let's get rid of this. And I can see that I'm going to need 3 calcium ions. So 3 of these Ca2 plus ions. And I'm going to need 2 of these phosphates. So 2 PO4 3 minus. And that's that. For the next one I have cobalt, let's see, yep, cobalt 2 nitrate. So that's CO with a 2 plus, and nitrate is a 1 minus, so NO3 two nitrates, and sodium hydroxide, that's NaOH, are mixed. I know, guess what, nitrate's always soluble. This is an alkali metal, so it's always soluble. So the insoluble thing is going to be calcium hydroxide, or cobalt, sorry, cobalt 2 hydroxide. So here we go, we've got cobalt, and hydroxide is a 1 minus charge, so I'm going to need 2 hydroxides. So now I know what ions I need to make that product. Oops, I'm on a roll. So I need 1 cobalt, so that's CO2 plus, and 2 hydroxides, 2 OH minus. And that's balanced, it's good. Done. So gotta know your solubility rules and your polyatomic ions.